revolutionizing the way that you learn. Need math help? Well, come and have your turn. Stress-free learning.
Stop comparing yourself to others. Be in competition with yourself.
Boom! Okay, today what are we doing? Today we'll be doing maxima and minima and also rates of change. Okay? Maxima and minimum. Let's start with that. Maxima and minima means the minimum or the maximum certain values for us to satisfy that equation. So let's start with an example so that you see what I'm talking about, right? So my question says, given a cylinder of volume 200 centimeters cubed, because it's a volume that's to be cubed, find the maximum dimensions, right? The maximum dimensions, what does that mean? That's where maximum comes into play, right? So what do? We don't have to draw the shape of it. You can if you want. We know that the dimensions that we need is the h, the height, and the radius, right? Those are the two dimensions that we need to find. So what do we need to draw first? We need to have at least two equations, right? So what two equations can you think about in a cylinder and finding volume? I'll think about volume is one and also surface area. So let me draw my surface area equation, and you should remember this somewhere or should hopefully go and cram it now. Surface area formula for a cylinder is equal to 2 pi r squared plus 2 pi r h. Right? That's my equation for surface area. And also my equation for volume, which I should write down because I need two equations, is also it's pi r squared h. Right? That's my equation for volume. Right? So now since they gave me volume, I'm working with volume. Okay, so let's work with volume, with the values that we are given, because if they gave us surface area, then I will start working with surface area. But since I don't know any values for surface area, there's 1, 2, and 3 unknowns in the surface area formula. So I have to start with the volume formula because at least there's only 2 unknowns, right? So my volume is 200, which is equal to pi r squared h, right? So I know one variable. So there's still 2 unknowns. What do I do now, right? That's why I have a second formula. So I have to write this formula in way so that I can put it into that formula, right? So what's easier to do? Write this equation in terms of r or write it in terms of h? I would say write it in terms of h because h doesn't have a power, doesn't have an exponent. So in terms of h is equal to 200 over pi r squared, right? Because I just divided that both sides by pi r squared. That's how I end up with h is equal to 200 over pi r squared, right? Now I have that equation, right? I'll call that equation 1. Let's call it equation 2 and this equation 1, right? So now, what do I do once I'm here? Once I'm here, I want to substitute 2 into 1. So I'll write here equation 2 into equation 1. Surface area is equal to, so what does my equation look like after I substitute? It'll be 2 pi r squared, which doesn't change because there's no h, and then 2 pi r, and then this becomes 200 over pi r squared, right? Because I substituted the value for h that I have from the other equation, right? So because I know that the r and h dimensions for both either the volume or the surface area are the same, because this is still the same cylinder. It's just the volume and the surface area, right? So now I substituted there. What do I do next? Of course, as you can see, I try to simplify. That there will cancel out with that. So that will only be left with to the power of r, right? To the power of 1. So this will be 2 pi r squared plus 2 pi times 4. So wait, hold on. Let me not do that because I can simplify this a lot faster, right? So also what else can cancel out? The pi's can cancel out, right? Because this is 2 pi, this is over 1, right? So pi's will cancel out and r squared will cancel out. You'll be left with r at the bottom. Right? And 2 times 200 gives me 400. So I'm left with 400 over r. That's what I have. I have 400 over r. So now, the important thing about maximum and minimum is that you have to find the first derivative. So in this case, it will be SA prime. I have to find that and equate it to 0. That's how I find the minimum and maximum dimensions. So maxima and minima are found when you find the first derivative. So what do I mean by that? This is what I mean. SA SA prime is equal to 0 for both minimum and maximum. So either they ask you minimum dimensions or maximum equations, it's the same procedure. Because if it's a minimum, surface area prime.
It is in silence where great ideas emerge. So you need to have those moments when you have nothing to do and you are just sitting there. A lot of people struggle to have that time because then when you finish your work, you're out there on your phone looking at social media, comparing yourself to other people, it's etc, that type of stuff. You have to have moment of silences, like be with yourself, be one with yourself, be one with your thoughts, because that's where your great ideas come from.
Prime must be equal to 0, right? Or volume prime must be equal to 0. If they're fighting for maximum, the surface area prime must be equal to 0, right? So now once we have that knowledge, what do? We substitute, we find what SA prime is, right? SA prime is equal to 2, so this will be 4 pi r plus, hold on, before I do that, right? I want to derive this equation. But it's not in the right format to derive, because I don't know how to derive 400 over r. I want to derive r in terms of r. So how do I derive r to the bottom? I have to get it to the top first, because that's one of the prerequisites of deriving. So SA, because I haven't derived the rate yet, I write SA, not SA prime. So this becomes 2 pi r squared plus 400 to the power of r to the negative 1. Because if I bring the r from the bottom to the top, I have to make it to the negative 1. Because r to the negative 1 is the same as 1 over r. Right? Put on your calculator, see what it gives you. If you put 1 over 2 and equal 2, and then you find what the answer is, and 2 to the negative to the 1, right? So now we have this. Now I can find the derivative. SA is equal to SA prime now, because I'm deriving it. SA prime is equal to 4 pi r plus, sorry, it's not plus because this is the power of negative 1, so it will be negative 1 times 400, which becomes negative 400 r. Negative 1 minus 1 becomes negative 2, right? This is what I have now, right? But it must be equal to 0, right? Why? Because that's how I find the minimum and the maximum dimension, right? Once I have that, now I want to be able to solve this. So I want to bring the r back to the bottom, right? To the denominator, so that I can work with it. So it'll be 400 over r squared. Now it's positive because it's in the bottom, it's in its right place, right? Because if it's negative 2, it's saying that I'm not in the right place, I should be at the bottom. So if this was r negative 2 at the bottom, it means that it's supposed to be at the top, right? So if I bring it to the bottom, it becomes positive, which is now equal to 0. How do I solve for this? What I think I should do first is get rid of all the fractions. How do I get rid of all the fractions? I multiply it through by r squared. If I multiply 0 by r squared, it's still 0. So the only one that will change is this one. So it will be 4 pi r cubed minus 400. Because if I multiply 400 over r squared by r squared, it becomes the r squareds will cross out with each other, right? And if I multiply 0 by r squared, it's still 0, right? Now, where am I? Look where I am now, right? So let me look at this. How do I solve for this? But look, I only have one variable. This can't be hard to solve. So what do? I take the 400 onto one side. So it becomes 4 pi r cubed is equal to 400, right? This is easy now. So what do? Again, I take the 4 pi onto the other side, and then I cube roots everything, right? So the answer for this will be r is equal to 3.17 centimeters. Remember units, right? Don't lose a mouthful for not putting your units on. So now once I have that, what else can I do? Now I can find what r is, what h is, because they say find the minimum dimensions. So this is one dimension, this is just r. I need to find the other dimension, which is h. So h would be equal to, right? H is equal to, we know what h, the formula of h is, right? So we want to use that. What's there? What variable is the only one that's missing there? R. And we just found what that is. So it'll be 200 over pi 3.17 squared. And then we know what h is, and h will be 6.34 centimeters. Right? So these are your two maximum dimensions for that volume that we are given for the cylinder. Now, let's go look at rates of change, right? Some interesting stuff under rates of change. Let's look at that. Okay, now looking at rates of change. Okay, what are rates of change? Okay, let me show you what rates of change is. Example, f prime of x, right? F prime of x is equal to instantaneous rate of change, right? So f prime of x is also equal to the average gradient, right? So this is instantaneous rates of change, right? Rates of change. Instantaneous rates of change with respect to x. This is also equal to average gradient, right? We already know this. This is stuff from a couple chapters back. Instantaneous rates of change is the new thing. Average gradient, we already knew that, right? So now let's do an example where we speak about the rates of change. Example 1, right? And we have x of t it's a distance formula. Let's say that we're using this as a distance formula. So we say x of t is the change in distance over time, right? Because the t stands for time. So this would be in meters, right? So this would be, let's say, a person walking or a person flying or whatever the case might be, right? Person driving or something like that, right? So now it says, the question says, find the rate of change at 2 seconds. Right? So we want to find the rate of change at 2 seconds of this person walking or this person in a car or whatever direction that they're moving in, right? That's what we want to find. Right now we only need to find the value of the instantaneous rates of change, right? So what do we know about instantaneous rates of change? We know that instantaneous rate of change is equal to the first derivative. So if it's equal to the first derivative, what does that mean? It means that we need to differentiate x of t in terms of t, right? So if we differentiate x of t in terms of t, we have x prime of t is equal to 6t squared plus 2, right? This is what we have after we differentiate, right? So we're looking for find the rate of change at 2 seconds. So again, t is time, right? So we could have written this is t is equal to 2, right? That's a 2. Now, t is equal to 2, right? So now we have, let's say, find the rate of change, right? So now what do we need to do? We need to substitute the 2 into the equation. So this will be x prime of 2 is equal to 6 2 squared plus 2. And basically, that's exactly all we had to do. That's what we are looking for. That's the rate of change, which is equal to 2 squared 4. 4 times 6, that's 24 plus 2, 26. So this will be 26 meters per second. Units are very important, especially in this section. Units are very important. Do not forget your units. Put your units on meters per second, because this is measured in meters, so therefore it has to be meters per second, because the time is in seconds, right? So let's say, for example, they ask you find the initial distance that this person has traveled. What do you do then? What you do basically is you substitute 0, because initial means that the beginning. What was the beginning value? The number at the beginning, what time had that person moved? 0 seconds. So that's why you would just substitute 0 into the equation x of t, and you would find that the person hasn't moved at all, right? But the equation could have been different. The equation could have been 2t cubed plus 2t plus 3, right? And then if we say, what is the initial distance the person has traveled? At 0 points. They won't tell you at 0 points, but you should know that initial means that it's at 0 seconds. So if I substitute into this equation, I would have 2t, 2, 0. So this will be 0, and that will be 0, plus the 2 that's remaining. So the person would have traveled 2 meters before the time it started. So that will be the initial distance. But in this case, the initial distance is 0. Since if you multiply t, 2 times 0 will be 0, plus 2 times 0, which is also 0. Right? So that's basically it on rates of change. So now we'll get into looking at the calculus of motion. The calculus of motion, very similar stuff to this. So what is the calculus of motion? Okay, let me show you what it means. It's saying that the displacement, this is seeming more and more very similar to physics. That's if you do physics, right? So displacement is equal to, what is displacement?
I cannot stress enough how important time management is, because some of you guys will fall off in university because you don't know how to manage your time. You have to know how to manage your time. It's the most important thing.
You can write it in terms of S of t. This is the universal form. You can write it in whatever form. You can write it as x of t, d of t, as long as you know that S of t is just represents displacement, right? So this displacement. So what is velocity? Velocity then is equal to, again, velocity is from distance to velocity, from distance to speed, from distance to rate. That's basically what displacement to velocity is. So the velocity then would then be S prime of t, right? Why? Because it's the rate of change of displacement. That's what velocity is. It's the rate of change of velocity. That is d over t, right? So velocity. Once we have velocity, what's left? There's only one more thing that's left in this, and that is acceleration. So what is acceleration here? Acceleration, if you look at it carefully, you can denote, note the word, that's a good word, right? You can denote that the acceleration would then be the second derivative, right? Because it'll be, velocity is the rate of change of displacement. So S of t divided by time, right? D over time, distance over time, right? So velocity would be velocity over the rate of change of time. So that's how it becomes second derivative, right? So it becomes S double prime of t, and that is acceleration, right? So these are the basic things that you definitely need to know under the section of calculus of motion. Let me write it here. Oops. So, calculus of motion, right? So, it's only right, let's do an example, right? So that we understand exactly what I'm talking about, right? So, let me erase. So, example 1, right? So let's do example 1. Example 1, what does example 1 say? It's saying S of t is equal to 3t cubed plus 2t squared plus 4. The unit, because again we're dealing with displacement now, so we need a unit of measurement. This is in meters, right? This is, let's say, displacement of a car, for example, right? It could be displacement of anything. So, but we are assuming it's a displacement of a car, right? So now it says determine the acceleration, no, the velocity. Sorry. It says determine the displacement velocity and acceleration. But at this moment, we can't determine determine that. We can only determine, if they give you like this and they don't give you any values, it means that they want you to write it in terms of a formula. And you know you can do that. But since in this question they said that all of this at t is equal to 10 seconds. So we want to determine all these values, all these quantities at t is equal to 10 seconds. Okay, so how do we do that? Displacement, let's find displacement first. So s of t is equal to, s of t, what do we do in this instance? We just replace wherever we see t with 10 seconds, which is 10 cubed plus 2 times 10 squared plus 4, right? This will give you 3204, 1 unit meters, right? That's the displacement that the car or whatever has moved, right? And then question B is asking us to find what the velocity is. What would the velocity be? First of all, what do we need to do before we substitute any value? We need to determine what the velocity formula is. And we know the velocity is, if we look here, the first derivative. So we have to find out what s prime of t is equal to, which is equal to 9t squared plus 2t. So that is the formula for the velocity. So now since we have the formula for the velocity, what do? We substitute. Wherever we see a t, we put 10, right? So this will be s prime. This is s of 10. And this will be s prime of 10 is equal to 9, 10 squared plus 2 times 10. And if you calculate this, this will be 900 plus 40. So this will be 940 meters per second, right? Units, do not forget your units, right? Look at that speed, going crazy, right? So let's do C. C, again, we can't just substitute 10 right as it is right now. Why? Because we do not know what the formula for acceleration is. But do we know how to get it? Yes, we do. We need to find the second derivative. What is the second derivative? S double prime of t. What is that equal to? So we derive what this equation is. So it becomes 18t plus 2. Okay, so s double prime of now we can substitute because we have an equation for the acceleration, right? So the acceleration is equal to, what is it equal to? Wherever there's t, I'll put 10. So this will be 18 times 10, 180 plus 2, which becomes 182. Sorry, I made a mistake here. Okay, note of this. This was supposed to be 4. This was supposed to be 4. I don't even know how I got the same answer over here. But that was supposed to be 4 because I said 2 times 2 becomes 4, right? So in this question here, this will become 4 and this will be 4. And then it will be 180 plus 4, which gives me 184. Now it's meters per second squared. Why? Because this is acceleration. And that's the units of measurement for acceleration. Those of you that do physics would understand, and this should be a breeze, right? This should be a breeze for all of you. So yeah, these are your free marks. You should collect them, get them, bag them, and pass the trick like it's nothing, right? Boom, okay? Go and check out the next video.